Excellent. Welcome, everyone. I think we're getting everybody in here. Whoops. All right. Let's see. We are getting everybody in from the waiting room. So glad you are all here. All right. Looks like we've got everybody in, I believe. All right. All right. Hello, everyone. We are so glad that you're here. Welcome to the July meeting of the Salt Lake City R user group. We have been meeting remotely for the past couple months, and we know that has been brought several, have been bringing people to us, both who are local here to us in Utah and some people who are from further away. And we are really glad to have you all here. We'll just do a couple of short announcements before we get started. I think that most of you probably found us through our meetup site, but that is how we are communicating and communicating about our events and whatnot. And we are we're part of the we have support from the R consortium, and we're part of the global group of R user groups. And as part of that, the R consortium code of conduct is applies here in this online space as much as it would if we were meeting in person. And so this is a space that we want to be friendly and professional, and that applies to what we're doing here. So Mark and Andrew and I are three of the organizers here, and we will be moderating comments. So you all should be muted, and I think we have it set so that you can't unmute yourself or screen share or whatever, but we would love to see comments, and we will, as we're going through the talk, if questions come up, we might be able to point James's attention to them. And if and then we'll have a time for questions at the end. And I think you're of course free to type questions at the end if you have them, but also Zoom has that raise hand feature. If you go, you can find by your name, you can find that raise hand feature if you want to speak at the end to ask a question. So this is our July meeting. James Blair is here to speak to us about big data with R. We are not having, no wait, I'm sorry, I said July. June, it's the June meeting. We're having our June meeting here. It's James. We're taking July off for the height of the summer, and then we'll come back together in August. Our August meetup isn't quite scheduled yet, but we'll get that on the calendar soon, so you can look for us there. And I think that is all of our announcements. So I'll introduce James a little bit. James and I actually work together. We both work for RStudio, and James is a solutions engineer at RStudio, and is someone who certainly has been super helpful in communicating about everything that he knows and all his experience in dealing with some of our how our pro product works, how our open source product works, and how they can help people who use R. And what we're going to be talking about specifically today is what do we do when we have these bigger data sets. So I'm really excited to hear about that. So James, thank you for taking the time to speak with us, and let's get started. Did I successfully unmute you?
There we go. I think.
Okay.
Okay.
Yes, awesome. There you are.
Great. Here I am. Great. Thanks, everyone. I'm, like Julia said, I'm James Blair. I work as a solutions engineer for RStudio. Our topic today is big data with R. There's a lot to kind of cover here. I'm hopeful that we get to most of the good pieces, and I'm hopeful that there's stuff that's new, or if not new, it's at least refreshing. I know that this topic kind of covers a bunch of different areas, and so hopefully it's not all review. Hopefully there's some things that are useful, regardless of kind of your experience level with R and with data of various shapes and sizes and things like that. If you can have an idea of what we're going to look at, first, I think it's useful to just kind of level set on what we consider big data as our users and our developers. And then we're going to start by looking at the dplyr package and how that kind of provides a gateway into working with larger data. And then we'll look at some packages that play nicely with dplyr and help us as our users investigate and work with data that is considered big or large. And then we'll talk about some best practices, and then I'll end with some resources that you can use to learn more, investigate further, kind of on your own if this is something that you're interested in, or if you find yourself in a scenario where some more information might be helpful. When it comes to big data, I think there's so many different definitions, right? You can talk about Facebook data, you can talk about government data, you can talk about these organizations that are just collecting massive, almost like unfathomable amounts of data on a regular basis. I think many of us probably aren't in those circumstances, almost might be, but I think, I think about the course of my day-to-day work, I'm not working with petabytes of data or terabytes of data. Sometimes I touch gigabytes, but like in most cases, it's not even that large. And so I think it's helpful to have kind of a working definition of what big data is, especially in the context of the conversation we're going to have today. And for me, I really like this definition. This was something that was proposed by another coworker of Julie and I's, Garrett Grohlman, a number of years ago. But he kind of made this mention of, as an R user, data is big anytime it's larger than memory or larger than RAM. And I think that actually works really well. And that's a definition that works really well as an R developer and R user, because R as a language is memory bound by default. So anytime you're working with an object in R, you're actually working with and manipulating an object that's stored in memory in RAM. And that becomes a limiting factor in regards to the size of data that you can work with, right? If I've got 16 gigabytes of RAM on my laptop, and so it's going to be really difficult for me to work with data much larger than that. Things are going to start to slow down, and eventually I'm going to start to run into issues that are hard to overcome. And now, again, the idea of RAM can be flexible, right? So my laptop has its available memory. You might work in an organization that's using a server with multiple terabytes of RAM. But regardless, this idea that R is memory bound, I think, is useful for us to work with as a kind of starting point for what do we mean when we say big data? And this helps us to kind of start to understand different ways that we can approach this kind of quote unquote big data problem as an R user. Just to give you an idea of some of the different like forms that I think we see big data in sometimes, right? There's numerous flat files that I'm sure most of us are familiar with: CSV files, Parquet files, TSV, JSON, so on and so forth, right? This list goes on and on. Maybe there's giant Excel files floating around that you need to parse on a regular basis. And then there's kind of, you could think of these as perhaps more mature or more built out solutions for big data, like databases or data lakes that may or may not be distributed. And this is kind of just kind of speaking from my own experience. When I left my undergraduate degree and entered my career for the first time, I was so used to just working with these flat files, and all of a sudden everything was in a database, and it was like this very like culture shock moment for me to try to figure out how to work my way around this external resource where all the data was without somebody just giving me a CSV file to work with. So we'll kind of talk briefly about some of these different specific formats and how we can interact with these as our users in some of our examples today. Now, like I mentioned, to start with, I think it's useful to have a conversation about the dplyr package. If you're unfamiliar, dplyr is a kind of cornerstone package of the tidyverse, which is a modern collection of R packages designed and built for doing data science and data analytics type tasks. So filtering data, reading data in, cleaning data, summarizing, understanding data. Just this process of working with data is something that the tidyverse as a collection of packages tries to make very simple and straightforward. And dplyr, like I said, is a key part of that ecosystem, and it's kind of one of the foundational cornerstones of that whole effort. It started back in 2014. On the right-hand side here, you can see a graph of the cumulative CRAN downloads of the dplyr package from when it was introduced up until the very beginning of this year, at over 22.5 million downloads. I'm sure we far surpassed that at this point in the year now, as we're 6 months down the road. So wildly popular package. You can see this kind of exponential growth as it's continued to become more widely adopted. And the idea, and we'll take a look at this in some examples. So if you're not totally familiar with dplyr, that's okay. We'll look at it here in practice. But I think one of the really interesting ideas behind dplyr is the fact that from the very beginning, and you can go back and look at the release notes and things like that, but from the very, very beginning, this package was designed to abstract over how data is stored. And I think that idea is really powerful. It's one that, like, I think a lot of people don't really get initially, but as we start looking at some examples today, I think it'll start to become clear why that is such kind of a key decision that was made in the design and the way that this package was laid out and put together. In fact, this comes from some of the documentation on the dplyr website. And that was, so Hadley Wickham is the author of the dplyr package. And this was something that he felt strongly about. And he says, dplyr abstracts away how your data is stored so that you can work with data frames, you can work with data tables and remote databases using the same set of functions. This lets you focus on what you want to achieve, not on the logistics of data storage. And that section that I have bolded there, I think is really kind of like, it kind of underscores Hadley's design philosophy on everything that he does. And that is like, let's improve human efficiency, right? And if as a human being, as a developer, as an analyst, as a statistician, as a data scientist, whatever role I'm in, if I have to think less about where the data is and I can just focus more on what I'm trying to learn from it, I'm going to do a better job. I'm going to be better at what I'm trying to do. And this was especially kind of significant for me, like I mentioned, kind of when I first entered this whole field of statistics and data science and analytics and everything like that. I didn't know a lot of SQL. I was really, really bad at SQL. And my first job, everything was stored in these SQL databases. And it was a handicap for me for a long time. It took me several months to get to a point where I felt reasonably competent to run like select star, right? Like it was a challenge to be able to get to this point where I felt like I could really start looking at the data because I didn't really know how to approach it. And the advantage that dplyr offers is, like it mentions here, just like use the same set of functions, whether you're working with something that's local to your R session or a remote database containing petabytes of data, you can use the same standard set of tools and functions to interact with it. And you don't have to worry about where the data is. You can just interact with it like you normally would, which I think is a really powerful idea. To give you kind of some concrete examples of what this means, the dplyr package has support for several different backends and methods of execution. So starting from the left, there's the R language itself. So native R objects like data frames and lists and things like that exist in memory. If you've used R before, you've likely interacted with these objects and created and manipulated these objects. dplyr works hand in hand with those objects and can be used to understand and manipulate those types of constructs. Data.table is a kind of an enhanced form, if you want to think of it that way, of an R data frame that adds some increased functionality and has a particular emphasis on speed and scale. So it's specifically tuned to work with large data in memory very, very efficiently. And there's a way to interact with data table objects using dplyr, and we'll take a brief look at that. You can use dplyr to interact with objects in Apache Spark. You can use dplyr for objects in databases of all shapes, sizes, and flavors: Oracle, Microsoft SQL, SQLite, MySQL, Postgres, Redshift, Google BigQuery. The list goes on and on. And then more recently, there's been a lot of work coming from Apache Arrow, which is a project designed to, with the goal of kind of abstracting and simplifying an underlying computational layer and memory representation layer for data analytics, languages, and tasks. And this list continues to grow, right? And both in terms of what's included here, but then also each of these kind of subgroups, right? As we talk about databases, like I mentioned, there's all kinds of different flavors and types and styles of databases that all work really well with dplyr. So let's start kind of small here in the realm of big data, and I do this intentionally, right? Like, because for some people, big data is like 500 megabytes, and that's totally fine. Like that, like I totally get that. And for other people, big data is 500 terabytes, and anywhere in between is kind of free game. So what I want to do here is I want to spend a little bit of time with some different tools that can help kind of, regardless of where you are in the spectrum, right? If you're working with a really big CSV file that somebody emailed you, you might want to know what are some techniques and tools I can use to work with this really quickly. If you're working on a large corporate database or data lake, you might want some tools and techniques that you can use there. And so I'm hopeful that in the course of the time that we spend together over the next 30 or so minutes, we can look at some of these different tools and techniques that kind of apply across the range of how big is your data, right? Regardless of how big it is, here's some things that we can use. So the first thing here that I want to briefly talk about is this data table package. And like I mentioned, it's kind of this high performance version of a data frame. It has this really fast built-in file reader. The emphasis here, again, is on speed and efficiency in terms of data operations and how data is being manipulated. If you've ever used data table before, and I actually really like data table. I used it for a long time before I kind of came across and was introduced to dplyr and the tidyverse and things like that. But if you've ever used it before, you might be familiar with the syntax. It has kind of a reputation for having a little bit of a different syntax than what you typically expect and come across as an R user, which is totally fine, right? It's something that you can pick up. It's like I said, I've used data table for a long time. But if you're not used to it, it can be a little bit intimidating to get started with because it just feels and looks and behaves perhaps a little differently than you would expect. And I always like to joke that anytime I had data table code written and somebody looked over my shoulder, it looked like a cat had kind of like rolled across my keyboard because it's just a bunch of open and closed square brackets and commas, and it starts to look a little less R-centric, if you can imagine that. So what's happened here is there's been this kind of effort in the community just recently over the past year, maybe 2 years, to say, look, we really like data table for its benefits, for its, for its speed and the way that it can handle larger data than, more so than a typical data frame or something like that could do. But what we'd really like is to be able to use dplyr with data table. Like that would be the ideal. And so Matt Dowell is the author and maintainer of the data table package. Hadley Wickham is the author and maintainer of dplyr. They spent some time working, kind of bouncing some ideas around, and this dplyr package was created. And the goal of this package is to allow you to write dplyr code that is then automatically translated into data table code. So if you're like, hey, I'm a big dplyr user, I like dplyr, now I've got some data that's pretty big and I'd like to take advantage of what data table has to offer me, you can do so without needing to relearn a new syntax or anything like that. And you get the benefits of what data table offers you. It's lazily evaluated, which means that it kind of performs some initial optimizations to make sure that what you're doing is as efficient as it can be in data table. And like it was mentioned, it converts this dplyr code that you write into data table syntax that's then executed via the data table package. Just a little note here, and then we'll look at a brief example. If you've used data table before or are familiar with the package, one of the ways in which it makes improvements or finds one of the ways in which it's kind of improved efficiency over the standard data frame is that it updates by reference instead of updating by copy. So anytime, just to give some context here, anytime you manipulate a data frame in R, say remove a column or update a column or whatever the case is, R will actually make an entire copy of that data frame and then persist the change in the copy that you've made. That has some really nice benefits as a user, especially when you're doing kind of interactive analysis and doing some experimentation, but it comes at a little bit of a computational cost to do that whole copying process over and over again. And so data table was designed to not do that. In other words, whenever I make a change to my data frame, that change is persistent. Whether it can almost be a little bit jarring at first because it can almost feel like, oh, I was just trying to see what this column looked like, but now all of a sudden it's just here. It's become part of what I was doing. So in order to preserve the natural feeling of what dplyr users have come to expect, when you use dplyr in connection with a tool like data table, that copying behavior it persists in data table. So in other words, it kind of overwrites the default functionality of data table, and instead of making copies, or excuse me, instead of updating by reference, it updates by copying. That's something you can turn off. It's an option that you can disable, but in order to keep the experience consistent with what you would expect as a kind of a standard dplyr type user, it automatically creates copies for you instead of updating by reference like data table does by default. Now, with that said, I want to take a look at this. So I'm going to pull up RStudio here. And And this is all, I have all the kind of example code and slides and everything like that in a GitHub repository. And I'll share the link here at the end. So you'll have access to all of this if it's something you want to go back and look at. So don't feel like you need to frantically try to copy things down and everything like that. So let me pull this open here. Let's see. Okay, so we're gonna look at oh, that's not what I wanted to do. We're gonna look at a couple of examples. I'm gonna load some packages here. Data table and dplyr are kind of the main ones that we're looking at, and then this dplyr package that we've been talking about. The other packages listed here, just kind of for convenience, I'm not going to dive too deeply into what we're specifically using them for. They go a little bit beyond the scope of what I want to accomplish in this demonstration. But here we've got a transaction, we've got a directory of files here. If I come over here, I can pull this open. If I look here, oops, there we go. We've got these 5 different CSV files. These aren't big by any stretch of the imagination, right? But you can imagine that these might be much more massive. Just for like convenience sake and making the repository small, I haven't included massive data sets. But if these were massive, we'd start to see some of the benefits of what data table provides. And here we can read all of these CSV files into a single object that we call transactions. And because we're using this fread function, if we look at the class of transactions, we can see that this is a data table that's been read in. So we now have this data table object that we can use. And if we're familiar with traditional data table syntax, then we're free to use that syntax as we would want. But if we want to take advantage of data table speed and efficiency, but we'd rather use something maybe a little bit more comfortable like dplyr, this dplyr package allows us to do that. And the way that we would use that package, if I come down, I'm going to skip over a few things here, which I think is okay. Is there's a function from dtplyr called lazy_dt. In fact, this is the only exported function from that package. And all this does is this creates a reference to this data table object that allows dplyr to perform translations between dplyr syntax and data table syntax. Right? So this new DT transactions object that we created is a reference to this transactions object, but it's special in the sense that it can respond to traditional dplyr type instructions and commands and functions and things like that. And I'll show you what that looks like here in just a second. So if we look at what this data set looks like, we've got 14 columns, we've got 250,000 rows. Each of these CSV files contains 50,000 observations. This is just kind of like simulated, bogus, made up data that represents some transactions from like a retail store or something like that. Now, I want to just kind of highlight a few of the things that we looked at when in the slide deck around what data table does and then how this dtplyr package works. So this lobster package will allow us to investigate kind of the size of objects in R and what sort of size they're occupying in memory. So if I look at this transactions data table, it's 23 million bytes. If I look at DT transactions, it's just a few more, right? They're very similar in size. This DT transactions table is just a few more bytes than the one that we were looking at previously. And then if we look at, my screen is being weird. And then if we look at this object size of both of these together, you'll notice that it's not, I haven't doubled the size of my object because DT transactions is simply a pointer to this transactions object that we already created. So all this is really doing is just showing like we haven't like created an additional strain on memory by duplicating the object. We've just created a reference to the original object. Let me see if I can reload this here really quick. Okay. Okay, so now let's take let's kind of look at an example of this. So if I've got my data table here that I've created with lazy DT, and I'm getting ready to do some aggregation or summarization. Let's say that I want to look at each month and I want to calculate the total sales of each month. Also, just like this is totally a side note, but I just noticed it, so I'm going to point it out because I think it's fun. If you are one of the users of RStudio who's been like waiting for rainbow parentheses to help you identify open and closed, like match parentheses and brackets, it's coming. And here's kind of proof of that. So this is the latest 1.4 daily build that that contains the rainbow parentheses. So if you're interested in that, and you like to live on the edge, this is available in the latest RStudio dailies, and you can go to global options, code, and then rainbow parentheses is an option you can enable in here to have this feature there. It's still kind of a work in progress, right? This is the daily build. It's not an official release, but this is coming in the next official release of the IDE. So exciting stuff. Okay, back to the task at hand. I've got my data table object here. I'm going to go ahead and run this command, right? We're going to calculate how many total sales we had each month. And we can see the resulting, the results here. But what's interesting is I have a little bit of additional information that's printed out with this, right? I see this like call information up here. And what this is this is dplyr taking my dplyr code and converting it into data table code. So if you're familiar with data table, you'll look at this and you'll say, yeah, that's what data table code looks like. And this is basically the translation of this into data table code, and then it's then executed against this data table reference that I've had. And so that's really kind of the magic of what dplyr enables you to do. I can use my consistent natural dplyr syntax that I'm perhaps used to using, but I still get all of the benefits of what data table has to offer in terms of speed and its efficiency and things like that. There's further examples in here of how we might look at this, right? So we can see different ways of how we can use this functionality and things like that. I'm not going to go through all of them just for the sake of time, but again, all these resources will be made available for you to take a look at, you know, on your own after the fact. Why have I been signed out? Okay. Wait, brief technical difficulties coming back. There we go. Okay. So let's talk now about kind of, well, let's transition a little bit from, I've got data that's local, maybe it's big, right? And one of the reasons that you might want to use data table is because I've got really large data, but it's not large enough that I've got a database, but it's large enough that I want things to run a little bit more quickly than they might in just regular kind of data frames and lists and things like that. Using data table is a great way to do that. If you want to use data table and have a consistent kind of familiar syntax, the dplyr package will allow you to do that, and it's great. Now let's transition a little bit further and say, okay, now my data is bigger, right? And now I'm looking at, I don't have a big CSV file. I've got a massive database or data warehouse that I'm connecting to or trying to connect to, and that contains all of my data. And this piece of the picture here, this piece of the puzzle is really kind of near and dear to my heart, because this was a battle that I fought for a long time, right? Like I felt really confident in my R skills. I felt really confident in my statistical skills and my analytical skills. My SQL skills were like my Achilles heel, right? Like this was what was holding me back. And so thankfully for me, on the first team that I joined after I finished my undergraduate degree, I had a coworker who was like really great at SQL and was easily bribed with brownies. And so I could make brownies and bring him brownies, and then he would write the SQL that I needed to have the CSV file that I could then load into R and work with, right? And that system worked really well. Like my brownie budget was a little bit ridiculous, but it was okay because I was able to get the work done that I needed to get done. But it's been really cool for me, having gone through the kind of that pain of being like, oh man, there's this disconnect between the tool that I know and use, which is R, and where all the data is, which was in SQL Server or Oracle or Teradata or whatever the case was. That gap was really hard for me to bridge. And over the past several years, there's been a lot of work done that makes that gap far easier to bridge and connect to in a way that I think is really clever and really helpful for our users and our developers. So what I want to talk about here is, okay, I'm an R user and I have data in a database. How do I connect to that database? And once I'm connected, what can I do, right? So connecting to a database really boils down to, I think, 3 critical components. One is credentials, right? The database needs to know who you are. If you're authorized, your database administrators are going to care deeply about this because they want to make sure that the access to their data is controlled and they know specifically who has access and who's working with the data and things like that. I need to know where the database is. So how do I get there? What's the location? That's typically the form of like a URL or an IP address or something like that I connect to. And then the final piece here is a driver which is the piece that translates the commands that I'm giving from the client to the database itself, right? This is how I'm able to actually communicate with the database. There's a few different kind of protocols that can be used for each of these different pieces. On the driver side, ODBC is a common protocol along with JDBC. At RStudio, we recommend and support the ODBC toolchain. I'll talk a little bit more about that here in a moment. I'm going to gloss through a couple of these just, again, kind of in the interest of time. But one of the nice kind of convenient ways that exist for managing and creating these connections to these databases is creating what's called a data source name, or what's commonly referred to as a DSN. And the reason this is great is because for me personally, if I have to like remember all these details, like imagine your phone, right? Like if I had to call my like sister and I didn't have her contact saved in my phone, I have no idea what her phone number is. I have no idea what her address is, right? But all that stuff is saved. I know what her name is. So it's really easy for me to call her. I pull up my phone, I type in her name, I can call her, I pull up my phone, I pull up her contact information, I can see her address, right? It's easy for me to remember that. And that's basically what a DSN does for a database connection. You give it a name like production SQL server or whatever. And then that name is a reference to a file, to an entry in a file that contains all the necessary components. What's the address? What's the port? What's the driver that's being used? What authentication mechanism you're using? All those details are stored in this other file. But all you need to really remember is what's the name of that entry, right? What's the name of that data source? And that's beneficial for the user in connecting because it makes it easier to remember how to connect. It's also beneficial from a security standpoint, right? If somebody were to get their hands on my code and see how I was connected to my database, they would see that my database was called production, and that gives them no details about how they might choose to integrate with the database and so on and so forth. Okay, following that, one of the nice things about working with RStudio and connecting to these external databases is, if you haven't seen this, and I'll demo this here in a moment, the RStudio IDE has a connections pane that can be used. And this connections pane gives you kind of this nice window into your database. Kind of in a way that you would almost imagine like a regular like SQL editor or SQL client doing. It gives you the ability to see the schemas and the tables and the contents of those tables and things like that without the need to open up like a separate tool or rely on a separate interface or something like that. And so we'll take a look at that here in just a moment. Again, there's some more information in the deck here, and this is all, again, included and linked in the repository. I'll share a link for at the end about additional details around connecting to databases and things like that. But I wanted to jump forward to look at the specific R packages that are in play here. So there's a few different R packages that come into play when connecting to these databases. There's the DBI package, which has been around for a long time and is kind of the generic, provides some of the generic kind of backbone around establishing and creating database connections. The ODBC package is a fairly recent, I say fairly recent, it's been a couple of years now, but it still feels recent to me, addition to this tool chain that allows you to create generic connections with an ODBC driver. And then there's a connections package that's kind of the newest of these three that just adds some enhanced functionality when using the RStudio development environment and these connection panes. And then there's also database specific or backend specific packages that create connections to specific data sources like Spark and sparklyr, Postgres using the RPostgres package, SQLite, so on and so forth. And then just kind of a little bit of a side note, but I think it might be helpful to know. At RStudio, we provide a collection of professional ODBC drivers that can be used with our professional products. These are essentially free add-ons for users who subscribe to any of our professional products. And this list is continually growing to support the kind of the main major databases that we see customers using. So Oracle's on here, Microsoft SQL Server, Postgres, Teradata, Snowflake is one it's in the process of being added. And so that list continues to grow. Now, as we get ready to look at an example of this pattern, I want to just talk about kind of the underlying philosophy, because I think that's kind of an important piece here. And this again kind of highlights a misunderstanding that I know I've had, and I think has in conversations I've had, I think is a fairly common misunderstanding. And that is that I often think of these databases, or at least I used to think of these databases, as like where the data lived, like data storage tools, rather than tools that not only store the data, but can also interact with and summarize and manipulate the data, right? So databases are great not only at storing data, but they're also really great at like computing and summarizing on top of that data. And that's helpful because the idea that I want to propose here, and that I think makes a lot of sense as the amount of data you're working with continues to expand, is that instead of doing what I used to do, which was like, okay, let me get the biggest CSV I can possibly find and bring it into my R session and start working with it there. Instead, let me keep the footprint of my R session relatively small. And instead, I'm just going to ask the database to summarize the data in the way that I want it. And then I'll bring that summary, which is typically much smaller than the full data set, back into my R session for further analysis or visualization or reporting or something like that. This pattern on the right-hand side here basically says, let's keep all of the data in the database and then ask the database to do the computation for us. And this has always been kind of a pattern that could be followed, right? Like if you are comfortable with SQL and writing and executing SQL statements, you could always push your computation to the database by writing these custom SQL statements and submitting those to the database. But what's nice is, as an R user, just like we saw with data table, there are tools built around the dplyr package that will perform this kind of conversion between R code to SQL for you without needing to worry about any additional, like, without you needing to necessarily worry about the details of, okay, how do I, now that I know what I want to do, I've got to figure out how to do it in SQL. Instead, I can keep myself with a consistent dplyr syntax and use that syntax as I go and work with my data. So let's go ahead and kind of take a look at this here. I'm going to pop back over into my RStudio session, and let's come take a look at interacting with data in an external database. So here I'm using the connections package, dplyr and dbplyr, and then this config package, which allows me to store configuration credentials in an external YAML file. And then here we're going to create this connection to this Postgres database. And so I can see over here in the top right-hand corner, the connections pane is now open. I have this retail schema that I can look at. And then within this schema, I can investigate. I've got a customer table. Here are the columns in that table. I've got an orders table. Here are the columns in that table. So I can do some kind of preliminary exploration of the data that I have available to me here in this connections pane. Now that I've got this connection to the database that I've called con or con here in my R session, and if we look at this, in fact, let me just do this here. If we look at the class of my connection, right, it's this connections object created by the connections package. And I'm not going to dive too deeply into the connections package, but the advantage is it allows the connections pane to work, even though we're using our Postgres package, which doesn't have native support for the connections pane. So this connection _ open function allows me to have this functionality up here in the top right-hand corner, even though the R Postgres package hasn't specifically implemented a connections contract. And that's the advantage there. So now that I've got this connection here, the next thing that I want to do is I want to point to a specific table. In this case, I want to point to the customer table. So if we say, okay, let's say customer is, and I can use this TBL function that comes from dplyr, and then I can pass the connection that I've created to my database and the name of the table that I want from that connection. So I want the customer table from this connection, and I'm going to call that object customer here in my R session. Well, I've run this, and if I now look at the class of customer, I can see that this is a reference to an external connection, right? This isn't actually the data from the customer table. It's just a reference to the customer table that's still in Postgres, right? I haven't brought anything into my R session. I've just created a reference to some data that's in a Postgres database in some server somewhere. Now I can do the same thing for the orders table if I want. I can reference orders from my connection. I can look at the class of that. I'll see that it's the same thing. And then what's nice about this is I can now start to kind of look at how this is working. And one way of doing that is using this show query function. This function comes from the dplyr package, or excuse me, from the dplyr package. And what this does is this will show me the exact SQL command that will be executed whenever I evaluate some object that's a reference to an external table. So again, this orders object is just a pointer or a reference to this orders table. And then if I were to execute this, so if I came and created a new chunk here and I said orders, here I see the first 1,000 rows of this external data of this external database table rendered here in my R session. And the command that's executed is this select star from orders. And if I were to change this, if I said, okay, let's do orders, and let's say I want to do orders, I want to take the first 6 rows of orders, right? Well, here I have the first 6 rows of orders. How did that happen? If I look, what I might think is I might think that this like ran like select star and brought the whole thing into R and then filtered to the first 6 rows. But if I look at the query here, I'll see that I'm actually limiting to the first 6 rows when I execute the query. So what's happening kind of behind the scenes here is that dplyr and this other package called dplyr are taking the code that I'm creating and translating it into SQL that is then being executed against the database. And this is really, really powerful for a couple of different reasons. One is, as an R user, this goes back to the point that Hadley made in the documentation for dplyr, right? If we come back to that statement for just a second, where he says, look, we want to focus on what we're trying to do, what we want to achieve, not on the logistics of data storage. And if I come back to my R session, I don't like, I know that I just want to look at the first 6 rows of this data. I don't need to worry about whether or not this data is a local data frame, a data table, an external table in a database, something in Spark that I'm accessing, and a Parquet file that I've read into Apache Arrow. It doesn't matter. The way that I work, the functions that I use remain the same and they remain consistent. And dplyr takes care of translating this into whatever it needs to be translated into in order to get the result that I want. Just to kind of look at this, if we look at something a little bit more involved, right? If we come in here and let's take our, I know I'm skipping over a few pieces here, but if we say, okay, let's create a new column in here, right? And in this case, this is, like I said, this is kind of toy data. This isn't a specifically or a particularly meaningful column, but we're going to create this new column that contains an average of some other column. And if we do this, we see again that this translation takes place between the code that I've written in R and the SQL that's generated to be executed against the database. And this works really well because like there are translations that have been made for common kind of database type or arithmetic type functions. So for example, here we see that we're taking the mean of a column. Well, my database, in this case Postgres, doesn't have a mean function. But dplyr recognizes, oh, we're taking the average. We know we know what mean is. We're taking the average, and we also know that the equivalent function in Postgres is this avg function. So this automatically gets translated to the equivalent SQL statement that will give me the code that I'm particularly interested in here within my R session. And this works for most standard dplyr verbs and functions and things like that. So if I wanted to take my orders and I wanted to say, let's look at what columns I've got. So I want to take orders and I want to count customer ID, range descending n. So here I see that customer ID 41 had the most orders, customer ID 85 had the second most, so on and so forth. And then if I look at the query here, I can see the query that was built in order to get the result that I was interested in here. And we could even add in another statement here, and we'd see the adjustment being made on the SQL side. So if we come back here to this pattern, right, of pushing our compute to the database and then collecting the results back into R, one of the things that exists, I didn't show this, let me come back into my RStudio session for just a moment. One of the things that exists here is if let's look at orders again, right? So if I say, let's look at the number of rows in orders. So there's 100,000 rows in this orders table. But if I just type in orders here, I only get 1,000. This to me is actually really clever because what's happening is dplyr and dplyr are working together. And they know that I'm pointing to an external database. And this database might potentially have billions or trillions of records. And if I, as an R user, forget that fact for a moment and just say, oh man, I don't remember what columns are in orders, what columns are in there, I don't want to accidentally trigger some process that's going to return or try to return billions and billions or trillions and trillions of rows into my R session. And that's a recipe for disaster. So instead, what happens is whenever I run like a command like this, by default, the values that are returned are capped at 1,000 rows, so that I can get an idea of what's going on, but I don't accidentally bring in so much data that it brings my R session to a screeching halt. Now, if I wanted to collect the full results here into my R session, I could do so using the collect function. You can say local orders is collect orders, which will bring that entire table. So now if I look at the dimensions of local orders, I see that this is now 100,081 rows and 3 columns, and it's just a local data frame, right? I'm no longer pointing to the external data source. I've collected all the observations from this table and brought them here into my R session. And this collect function works not only just for entire tables, but also it works in connection with any of the other SQL statements that we've executed. So here, if I want to count by customer ID and then arrange and then collect this, we'll call this customer count. There we go. And we see this local data frame that represents the results of this query that we've now collected here into R. Now, coming back to this idea, what we want to do is we want to allow ourselves to write consistent syntax using dplyr, push all of our computation into the database, and collect only the results that we're interested in back into our R session. And this pattern allows us to work with data that's much larger than we would typically be able to work with a standard R session or within a standard R environment. So for example, I spoke at Spark Summit, which was Databricks Spark conference that they did last week. I did a talk in connection with some of the individuals from Databricks, and we analyzed a data set of billions and billions of records, all from R, using Spark and Sparkly R without bringing all those records into R, right? We were able to execute commands, summaries, understand our data without needing to bring all that data into our R session. If you're, just to kind of round this out, we've looked at this pattern over here on the right-hand side where we're able to use dplyr to push computation to data table, to push computation to the database. You can push computation to Spark. You can push computation to Arrow. Lots of different options here. You can also just execute regular SQL statements against that, against those objects as well. So if you're comfortable with SQL and you know, hey, I know that I can come up with a SQL query that I need to write this, you can go ahead and execute those SQL statements as well, just by running. There's a few different ways of doing this, but there's a db get query command that you can use to point to a connection and then say select star from orders limit. Right. And if I had dbi loaded, that would have worked. There we go. Okay. So we can submit actual specific SQL queries as well, if that's something that we're interested in doing. And then kind of one last thing that I think is maybe helpful to show here, and this is included in the example in the example repository here, and that is if I come in and look at doing something like maybe I've got a Shiny application that I want to share and create, but I want the Shiny application to be backed by the databases that my company has in store and in place. This pattern of using dplyr and other tools to connect to these databases allows me to do just that, right? Here I have a Shiny application that's been published, it's distributed, anybody in my organization can come see it. They can come in here and filter, this is a fairly straightforward application, but they can come in and filter to different dates. And now this is all executing queries against my database and only bringing back the summary statistics into R that I'm particularly interested in. So this prevents me from needing to load massive amounts of data into my R session just to support something like a Shiny application. Instead, I can have my Shiny application submit queries to my database and bring the results of those queries back into my R session for me to continue to work with and analyze, or in this case, for me to present to the users of my Shiny application. Just kind of some notes on where you can go for additional information. db.rstudio.com contains lots of detailed information about working with databases and external data sources from within R. If you're interested in or are using Apache Spark for data analysis, spark.rstudio.com has some great information. And there's some associated additional links here that might be helpful. RStudio community is a great resource for going to look for either help with questions or looking at what other people are doing. It's an active community. Myself, members of my team, several employees from RStudio frequently respond to questions that are posted there and provide input when people have questions there. So feel free to visit that resource. And then there's several GitHub repositories that are related to packages and tools we've discussed today that you can kind of keep track of if that's something that you're interested in, to kind of see what's coming in new development and how progress is being made, as well as if you have questions or run across issues, you can file issues in those associated repositories. I know that we're coming up on time. I think we've got a couple minutes. I can field a couple of questions, but just want to say thanks everyone for tuning in and for joining today. This link down here at the bottom, bit.ly and then slc-rug-big-data will take you to the GitHub repository that contains the slides and the sample data and the R scripts and everything that we've walked through today. Like I said, there's a lot that we maybe didn't quite get to, but all of it's there if you want to go take a look. And again, thank you everyone for your time, and we'll see if we've got a couple minutes for questions here.
Awesome, James. Thank you so much. That was really interesting. Well, yeah, there are a couple of questions here. One thing that you said to just kind of kick us off that really resonated with me with my own experience of dealing with both large data sets that are in SQL tables, and then working with SQL and R at the same time, is thinking carefully about what compute happens. And one thing I often said to myself and also to other people, to try it, as I would onboard them or say here's how to learn R if you would they were already SQL users, was thinking about using SQL for aggregation and counting up and basically anything that SQL could do, and thinking about bringing things into R to do the things R was really good at, which is the modeling and the data visualization and whatnot. And I wondered to kind of kick us off with just these couple questions at the end, when you see that connection being oh yeah, let's move the compute from here to here, when you often see that being useful.
Yeah, I think it's kind of tricky because there are certain things where making that migration is a little bit more challenging, right? So modeling efforts, it's difficult, not impossible, but it becomes more difficult to train and tune machine learning models while keeping all of your data in the database, right? A lot of those methods require things kind of beyond what you could craft in something like SQL. But for just standard kind of summarization and trying to understand data, I think a lot of that effort can be offloaded, and a lot of just so I think really the tool set kind of governs that to a certain degree, right? dplyr fits a certain kind of corner of data analysis, understanding and summarizing and just kind of digging into data. And that tool chain works really well with offloading this computation and things like that. As you start to look at more intricate types of analysis, that's when you start looking at, okay, well, maybe I need to kind of bring some of the data in locally because these tools don't have good translations, or it's just difficult to create a good replica of what I'm trying to do in the database, in Spark, in whatever tool I happen to be using. And I think that relates to some of the questions that have come in on the comments, right? Like, there are
Yeah,
certain
like spread
functions
and
that,
gather.
exactly, yep, there are
Yeah.
certain functions that don't have good translations now for one reason or another. And when you start bumping up against those, that's when it's time to consider, okay, well, what are my options now, right? Like, I can craft my own SQL statement, that's always an option, or I can start looking at bringing in a subset of the data and starting to understand that subset and kind of chunking my data up in that way. But I think, for the most part, I think the tools kind of help dictate where those lines are, right? If the translation exists, if it's something you can do in dplyr, odds are it's going to work well in a remote data source. And
Yeah.
it's just a matter of setting that up.
Yeah, yeah. Maybe so several of these questions are kind of about the translations. And so one is kind of about like partition by versus group by. And as I understand it, like group by in SQL like would be more like group by summarize, and partition by like you, James, I'm not the like world's best SQL person, but I think partition by is more like a group by mutate. Um, and I'm gonna push my child out of the window here. But there are issues where we don't have the connections right there, and then like especially with different backends, like someone mentioned Hive here, and like different
Yeah.
backends are supported in different ways. So can you talk speak just a little bit to that there are these differences sometimes, and like how to address how to
Yeah,
work with some of those limitations?
yeah, certainly. So SQL is kind of a funny thing because every vendor has its own flavor, and like the different flavors behave differently or expect arguments in different ways or expect slightly different syntax. And that can make things challenging, especially when you're trying to create a tool like dbplyr that does this kind of auto magic translation for you. And so what happens with dbplyr, just kind of at a high level on the mechanics in the back end, whenever you submit a dplyr statement that gets translated to SQL via dbplyr, it runs through a series of translations. There's kind of a baseline kind of standard SQL translation that takes place, and then it investigates this particular backend that you're connected to determine if there's any additional translation that needs to take place, right? So for example, when you want just the first n records returned from a result set, some SQL syntax expects you to say top n, some expect you to say limit n, right? There's different ways of translating that request. And so dbplyr has specific translations built in for specific backends. And so if you run across a scenario where all of a sudden, like, the translation isn't working as you had expected or anticipated, that's an opportunity to file an issue on the dbplyr GitHub repository and just indicate, look, here's a reproducible example of what I was trying to do. Here's what I did. Like, the number of SQL flavors continues to expand as more and more vendors come to market, right? And so it's hard to keep track and give priority to everything, but that at least puts it on the radar and lets us know like there's a missing translation somewhere. And we try to have good translations in place, especially for the drivers that we provide as a company, like I mentioned, and that covers a pretty good range of what we typically see in practice. But that would be kind of the place to go if there's issues with that translation piece, is the dbplyr GitHub repository.
Awesome. Thank you so much, James, for that presentation. Super practical and useful for so much of our real life work. We appreciate you taking this time. So we're gonna thank you all so much for coming, and stop recording and get this on. We will not have a meeting next month like we said, and we will get things up for our August meeting. So thank you all so much for coming this month.